Hi everyone, this will be the accompanying video for doing the study checks for the rest of Chapter 9, so what I'm calling Lecture 9B. So this will be the study check problems from the handout for Chapter 9, but it will focus only on sections 9.4, 9.5, and 9.6. So let's get to it. So the first problem, which you can find if you want a summary of the problems, up, like I said, on EC Learn, it's already part of the Chapter 9 handout. So it's telling us we have a solution is prepared by mixing this amount of sodium carbonate with this amount of water. And it's asking us to calculate mass percent. So these are the things which really should be drawing our eye. So if I was going to write down things that I've been given to start organizing my information, right, I know that the mass, and I'll just put an N for the sodium carbonate, is 15 grams. I know that the mass of the water is 235 grams. So for me, if I'm asking to find concentration, specifically in the units of percent mass per mass per volume. Mass per mass, I was right the first time. Wrote it wrong. So that's what I'm trying to find, and that's what I've been given. So the equation that I'm going to need to remember, like I said, I will give you your equation sheet, but this is something it's drawing our attention to. Well, I know percent, oops, I keep doing that wrong. I know percent mass per mass. It equals mass solute over mass of the solution. So hopefully that's clear enough on the screen. Mass solute, maybe I'll write the whole word for this one. Solute over mass of the solution. So if that's my definition, multiplied by 100. Let's keep that, everything consistent. So that's how we're going to calculate it. So if I rewrite what I'm solving for down here, I know my mass of my solute. I just have to identify what my solute is. It's whatever is in lesser amount, so it's my sodium carbonate. So that's my 15.0 grams divided by, I'm going to grab my calculator for a second, it's going to be the mass of the solution, which we know is going to be the mass of the solute, which is our sodium carbonate, and the mass of our water, which is 235. So 235 plus 15, if I add that up, I did this correctly, right? We should be getting a mass of 250 grams for the solution. So 15 divided by 250 is going to be 0.06, and then if I multiply that number by 100%, we get a 6% mass per mass solution of sodium carbonate. So that would be our final answer. That is our mass per solution, and then what we take a look was at one of the ones we were given, and it was. So it's a nice check to have. You don't always have that, but it's nice to have. All right, so we're moving on now to talking about molarity as a unit of concentration. So it's asking us to find the molarity. So what is the molarity of this solution of NaOH if it contains this much mass of NaOH? So right off the bat, we can see this is a little bit more difficult than some of the other molarity problems we've done. Again, if I don't know where to start, and sometimes you don't, write down what you do know, right? So we know we have a volume, and that volume is a half a liter, specifically of an NaOH solution. I know the mass of the sodium hydroxide that was in that solution is 6.00 grams of NaOH. It's asking me to find molarity, which I can know is the number of moles per liter, as by definition, of this solution. So I start with what you got and start with what you need to figure out. So if I'm going to solve for molarity, I better have moles of NaOH, and I better have volume of solution. So if I take a look over at my givens, well, I actually know the volume of my solution. It's a half a liter. So I do know the denominator already. That leaves one thing to solve for, and then I'm done. So I know if we go back a couple of chapters, I believe it's chapter 7, I can always go from grams of something to moles of something by using the molecular weight, as long as that something hasn't changed. So in this case, it would be sodium hydroxide in grams to moles of sodium hydroxide. That means all I need to know is molecular weight. So for us, you'd have to go to the periodic table to grab this. We'd add up the molecular weights of sodium and hydroxide. So let me just pull up, I'm sorry, I forgot I needed this information and I don't have it, so I am literally Googling it right now. Good, it is the number that I thought. To figure out the molecular weight of sodium hydroxide. So you'd have to find out the molecular weight of sodium, of oxygen, and then of hydrogen. So that's 23, 16, and 1. If we add those up, 40 grams per mole is the molecular weight of NaOH, or sodium hydroxide. So that's kind of like some side scratch work. So let's finish this off now. So we know where we're going. We need to get to moles NaOH. I know I have 6.00 grams of NaOH. I need to cancel out grams, so I know grams NaOH must be on my denominator, with moles NaOH on the numerator. I take a look here. If I had 40 grams of the NaOH, I would have 1 mole of that compound. So I'm going to run out of space on this slide, so what I'm going to have to do is clear some space off. So for some things that we don't need or have just used. So our calculations for molecular weight, we're done using them. So let's get rid of that. And let's bring this equation down over to here. So if I finish that off, I'll notice that I do, let's make sure our units cancel. Grams NaOH with grams NaOH, left with moles NaOH. So if I do 6 divided by 40, I get 0.15 moles of sodium hydroxide. That's how many moles of NaOH that are in 6 grams. So remember, we went between this conversion with molecular weight. So I take a look now. Do I know my number of moles of NaOH? I can now say, let's erase that question mark. And I can say, yeah, I do. So again, I've run out of some space, so I'm going to erase the things that we do no longer need because we're done finishing solving for them. So let me try doing this. Just to save space, I'll say that we already solved for this, and we find this out to be 0.15 moles of NaOH, so we did that work, so we don't forget. Let me finish off this work here, or finish off erasing the work. So let's pull everything together. We pull everything together. We know molarity is number of moles of solute per liter. My number of moles of solute is 0.15 moles of sodium hydroxide. And the volume of that solution was a half a liter. So the molarity of this solution will be 0.15 divided by 0.5. Two significant figures, mostly because I wasn't using a periodic table. I did it quick off the top of my head. I only use two significant figures in the molecular weight. If you use 3 or more, your final answer will be a little bit different than mine. So with did I mess that up? No, I didn't. 0.15 divided by 0.5, yep, 0.30. And don't forget my units of molarity, or you could also write technically moles per liter, and you wouldn't be wrong. But capital N, M, is the unit for molarity. So we should be good with that. Again, some of these problems, I make them seem long. It's mostly because I'm talking through every single step. With practice, you'll get faster at these. So we have another question now. So it's asking us how many grams. So instead of giving us the number of grams, it's how many grams of NaOH are needed to make a 75 gram solution of 14% mass per mass. So now we're starting to mix these ideas together, right? So let's organize what we were given. I know I have my mass of the solution is 75 grams total. I know my percent mass per mass of the solution is 14.0% sodium hydroxide. Again, that's all I've been given. What am I being asked to find? Is mass NaOH in units of grams, is what it's asking me. So I've organized my givens in finds. And so, again, we start pulling it apart step by step. Even though this kind of appeared after molarity, this is kind of the section where it's starting to mix ideas together. It's actually just as simple as doing the first problem we did with mass per mass percentage. So if I remember what my definition is of percent mass per mass, I know that's going to be grams of solute all over grams of the solution total, everything multiplied by 100%. That's what I'm looking at. So if I break things down, so effectively I have a couple of unknowns. Let's keep track of them. So I would need to know this number, 1, 2, 3 numbers to solve for this equation because 100% is just a number. So I ask myself, what do I know? Well, I know this number, and I know that number, and actually what's left is the one thing I'm being asked to solve for, so it's okay to have something unknown. So let's plug in our numbers. So I know my percent solution is 14.0%. That's going to be equal to, and I'm just going to convert this into my variables symbol so I know what I'm solving for. That's my mass NaOH in grams, and then my mass of the solution, I've already been told, is 75 grams total. And then I still can't forget, I'm going to try to erase this to save space. Part of the equation is still that 100%. So the first thing I can do is divide both sides by 100. This will turn this to 0.140. So 0.140. Since both sides are divided by 100%, it disappears. And then what we actually see is a unitless number. It's technically correct because percentage divided by percentage is unitless. So finish this off, multiply both sides by 75. So 75 times 0.14. I get the mass, let me put it on the same side. I'm getting that a mass of 10.5 grams is what will be needed to make this solution. So that's my final answer. That's how many grams of NaOH I need to make the solution as specified. So again, it seems intimidating to start, but write what you're given, where you're going, and then just start with a plan. And sometimes it's best to know where you're going, but sometimes you can start to work your way through. Oh, and let's just make sure we had that as an answer, and we did on our solution slide. There's our 10.5 grams. So, and again, so I'm walking through all of these, so even though I'm going to keep repeating these, you can skip these if you are comfortable. You can fast forward if you just want to see the answer. It is up to you how you want to use these. So even if you're doing this and be like, hey, I've done enough, you might have done enough. You can always come back. So just make sure you're comfortable. So again, we'll take another one of these concentration problems. So it's asking me for how many grams of aluminum chloride are needed to prepare a 125 ml solution of a 0.15 molar solution. And then it gives us a bunch of choices. So again, as our problems get bigger, we start organizing what we got. I know the volume of the solution is equal to 125 milliliters. I know the concentration of the solution, and I don't know if the book explicitly mentions this. When you see brackets, it's the shorthand that chemists use for concentration. So the concentration of the solution is given to me in the units of molarity, and I have a 0.150 molar solution, which is also equal to, and I do this a lot to remind myself what the units are, it's also equal to 0.150 moles per liter. So we're going to remember molarity, that big M, the capital M, is a complex unit. Complex meaning it's made out of more than one unit, right? 2 units, moles and liter. We're being asked to find, sorry I couldn't keep this one as neat as the last slide. We're being asked to find the mass of aluminum chloride. Ooh, that looked awful. The mass of the aluminum chloride, specifically in units of grams. So I'm going to put this up here in the top corner so we don't forget, but I'm going to erase the find column just to save space on the slides. So that's what we're being asked to find. So again, I'm a little over the board here with this, but in real life you want to keep your ideas close together on a page. So let's start with what I'm given, right? I know I have 0.150 mole AlCl3 solution. If I can set up a path from here, a couple of steps to get to the mass of aluminum chloride, right? Sometimes you can just start and stumble through, other times it's good to have a plan. If I take, let me start here. So this is going to be my plan. Not always, you don't always have to write down a plan, but sometimes it's good to if you get stuck. Right? I know I can start with my definition of molarity. So that's my, let me just erase it to make it fit. I know I have the number of moles, and I'm just going to use A for aluminum chloride for now. I know I have liters, I'm going to use S for solution. So let's do that. A equals AlCl3, and S will mean solution. So I have my number of moles of aluminum chloride, and I also have the volume of my solution in liters. So I could also multiply it by the liters of solution, and I would just be left with the number of moles of aluminum chloride that's there. Well, that's getting closer to what it's asking me to find, which is the mass. So I know, so if that's step 1 of my plan, step 2 must be taking the number of moles of NaCl3, and what I could do, is use the molar mass of aluminum chloride, and I get that right off the periodic table, and I can see that I'm left with the units that I want of grams of aluminum chloride. So this is a 2-step process. Figure out how many moles of aluminum chloride I have, and then figure out what mass that is by using the molecular weight. So that's our plan. So let's do that in 2 discrete steps. We'll start with plan 1. Let's just figure out the number of moles of aluminum chloride are in solution. So I'm going to actually erase all of this so I have as much space as I can use. So let's start with that. So I know my concentration, 0.150 moles. Man, I am not good at judging space. There's a whole skit from John Mulaney about that, of screwing up how much space you have to work with. Sorry guys. 0.150 moles of AlCl3 per liter of solution. That's the definition of molarity. I have 125 mils. If we go back to chapter 2, we should know our conversion. There's 1,000 milliliters in 1 liter of water. So 1, 2, 3, we move our decimal place over. We find out we have 0.125 liters of solution. Units of liters entirely cancel out. They're gone completely. So when I do out my math, and I'm done, and I'll bring this down here because I run out of space, it ends up being 0.15 times 0.125. 0.01875 moles of aluminum chloride are in this solution right here, what they're talking about. The 0.15 molar solution, if I have 125 mils of it, I'd have this many moles of AlCl3. And that makes sense, because if I had 1 liter, I'd have 0.15 moles of the aluminum chloride, but I don't have a liter. In fact, I have about, what is that, it's like 12% of a liter, right? Or whatever it is, 12.5% of a liter. So it's very, even smaller than that. I can't do math today, sorry. Oh, it is 12.5% of a liter. That's fine. Don't worry about that. It just makes sense it would have less moles of aluminum chloride total because our solution is just smaller. We don't have a lot of it. So what this effectively answered is that part, and now let me write this down so we don't lose it. So we have the number of moles of AlCl3. It's my 0.01875 moles. I'm not worrying about sig fig right now. We'll come back and readdress that later. I know the sig fig is wrong, but sometimes to avoid error, what we'll do is we don't do sig fig until the last step. So now for part 2, I need to go from the moles of AlCl3 that I have, and then I need to use the molecular weight, so maybe even draw it out as a plan. I need to use molecular weight to get to grams AlCl3. So what I'll need to do, again, is go to the periodic table and add up the molecular weights. So aluminum has a molecular weight of, let's find out, we'll get some extra sig fig here, 26.98 grams per mole. I grabbed that right off the periodic table. And then chlorine is 35.45 grams per mole. I know there is 1 mole of AlCl3. Sorry, there's 1 mole of aluminum and 1 mole of AlCl3, and there's 3 chloride, because we can see from the balanced chemical equation. So if I add that up, 35.45 times 3, the combined mass of the 3 chlorines would be 106.35. I add that to the mass of the aluminum chloride. So AlCl3 molecular weight is 133.33 units of grams per mole. And since I'm doing this while talking, let me just Google real quick so I don't waste your time. So AlCl3 molecular weight is 133.33. I was off by a little bit rounding. It says 3.4, but we're going to go with this because we have more sig figs than we need. So we're good with that as well. So 133.33. So let's apply this to our plan. So it seems like we've done kind of a lot, which we have. But if we get this into the process of how to solve these types of problems, they can go very, very quick. So there's my 0.01875 moles of my aluminum chloride. I'm going to use the molecular weight we just found. So in 1 mole of AlCl3, it weighs 133.3 grams of AlCl3. So I check out my units of moles AlCl3, cancel with moles AlCl3, and what am I left with is my final answer. So my 0.01875 times 133.3, 2.499 grams AlCl3. I'm limited to 3 sig fig. 2 point, that rounds up. That rounds that up. 50 grams AlCl3. Do I have that answer? And yes, I do. It is C. So we're in good shape. So I know that was a lot of talking. It was 24 minutes. So what I'm probably going to do is break this up again. Even though this is technically still part of part 2 of Chapter 9 lecture, that is the most theory, or most, well, not theory necessarily, the most equation-heavy section. So those are just want to give you as much practice as I could.